Okay, we're going to make a start to our final session of the day. I hope you've enjoyed your afternoon tea. Up next, we have Adam, who's going to be presenting about bsvars. Come back. There we go. Whoop. All right. That's right.
Thanks everyone for coming. And my name is Adam, and this is a joint project with my supervisor, Thomas Wojnek, who is, because of his severe back injury, cannot be here. So I'm here for him to do this presentation. And this is our organization, bsvars, and this is Thomas's package, bsvars, and then this is our package, bsvarSIGNs. And the metric stands for Bayesian structural vector autoregressions. And then this is by Thomas and me. So what this package does is that these are packages used by economists. They are the go-to models for analysis of policy effects, for example, monetary policy or fiscal policy. And then they facilitate the analysis of dynamic causal effects of the one isolated cause. So that's some difference between econometrics and statistics, where we only focus on forecasting. Here we are mostly interested in causal effects, but the accuracy of the causal effects is based on forecasting, because in the end, the dynamic causal effect is just the difference between two forecasts. So if the forecast performance is good, then the inference from the causal effects is good. And this model is also perfect for predictive analysis because, as I said, they are based on predictive models. And this commonly used in monetary policy and fiscal policy analysis, and also financial markets. So there can be extended to non-normal error terms, and then heteroscedastic error terms, and we can also have time-varying parameters for the autoregressive coefficients in the vector autoregression model. And also we can incorporate Bayesian hierarchical modeling for the hyperparameters. And so this is the only slide that will contain some map, so it's not too much. So this is the var equation for all the models in this family of packages. So yt is the vector of endogenous variables, and a is the autoregressive coefficient. And xt can contain the lag of yt, just like standard vector autoregression models, and also other exogenous variables that help predict the endogenous variables. And epsilon t here are the usual error terms in the statistical literature. And ut here is the what we call the structural errors or the structural shocks. So that's something probably new to statisticians. And they are related by this linear relationship, which is captured by the matrix B here. And we call this the structural equation. I think there's some similarity between this structural equation and the structural equation in forecast reconciliation, because they're also placing some restriction on the model. And I think in forecast reconciliation, the structural equation is to improve forecast. And here we are trying to improve the interpretability of the V, so that in the end we can isolate these shocks, the structural shocks, from the simple error term from the statistical model. And the usual assumption is that this structural shocks ut, given the past observations, they follow a normal distribution with mean zero and diagonal variances. But we can relax, and in the future slides, I will relax this assumption so that the variance here will just be the identity matrix. So some features of this kind of model, structural vector autoregression model, is that they facilitate a dynamic modeling of the system of equation variables, and then the structure of the economy is modeled by this B matrix here. So this B matrix really relates the error term from the var equation to the structural shocks, which is the underlying dynamic causal effect we are interested in. For example, one element in UT could be the monetary policy we are interested in, and the other could be fiscal policy that we are interested in. And we can also have time varying variances like what's displayed here, but we can also relax this assumption so that we only have just a identity matrix. So that in the end, the errors in these structural shocks, or each element in the structural shocks, they are uncorrelated with each other. That's what we mean by y-isolated shocks. So this is the how you will use the code to use this package. So the sign ILF and sign truffle here is how we define the sign restriction in this package. And I'm not going to the detail to explain for the economy reasoning behind this, why we set up the sign restriction like this, but just to show you that to set up this matrices is very easy. We just need to set up since we have 4 variables in this example, so we just need to set up a 4x4 matrix, and then also another 4x4 matrix for the sign truffle matrix. And in the end, if you plug these 2 matrices into the function here, you will get the result. And calling, so whenever you want to use any function in this package, you start by specifying a model. And here we can call this function specify bsvars $new, and then we feed it the data we have, and then the number of laps in the core equation, and then the sign restrictions. And then this will generate an R6 object that can be used later on. So I think when I first saw this in R, it was quite intimidating because I never seen anything like this in R before. But if you have used Java or Python before, I think this is similar to the syntax when you initialize a new class. So if you're familiar with that, then this is, I think, the exact same thing to initialize a new object from a class. And then after specifying the specification or the prior objects, then you can plug into this estimate method or function, and then specify the number of posterior jaws that you want to have. And then it will generate the posterior jaw inside this post object. So this just 2 lines of code, and then you can estimate the whole model, which is very straightforward. And we also have this focus bar, which is useful when you do Bayesian inference because it takes significantly longer time than frequentist methods. So you want to keep track of the progress. And so this is what most people here are interested in, forecasting for the model. So here, to do the forecast is also very straightforward. We just need to feed the post object into the forecast function, and then specify how many queries we want to forecast ahead, and then also finally just to make the odds. So all of this is done automatically, and then in here we will see these 4 variables and their future predictive values, also with the predictive input. And some other things we can do this in these packages are something called the forecast error variance decomposition, which is by definition a decomposition of the forecast, the variance of the forecast errors. And in this particular example, since none of them came so much, so it is not very informative in this example. But this is one functionality in the package. And another thing, probably the most important thing in structural analysis is the in-cause response functions. And this is what we mean by the dynamic causal effect. It's the difference between 2 forecasts. One is that we have no increase in the shock, and the other one is that we have 1 unit increase in amount of shocks, and then you can analyze the impulse response on that shock. So here, the economic background in this example is that we want to analyze the effect of a monetary policy shock, in specific a positive monetary policy shock. That means if the government or the central bank raise the interest rate unexpectedly by 1 standard deviation from the past, then this is what we will see in the 4 variables. So the second most interesting me here is the second variable here, which is real GDP. And from this example, it proves that if we have a positive monetary policy shock, then we will see real GDP to go down because this is actually -0.2. This is a negative number here. So we can see the real GDP significantly goes down in the future. Although this is in at the significance level of 68%, which is acceptable in the econometric literature. And so yeah, as I mentioned, so the result from the impulse response is depends on the forecasting performance behind the Bayesian VAR model. So if the forecast performance is good, then the impulse response are more reliable. And another plot or another functionality from the package is to compare historical decompositions. And this is just mean if you look at the past value of the 4 variables, how much each shock contributes to the variable. So here we have 4 variables, and also for shocks. Since we only identify the first shock, which is the monetary policy shock, so we can, if you focus on the darkest red, very short pin, then we can see how much the monetary policy shock contribute to each of the 4 variables. So the target audience for this package is first is academic researchers. So we want to ensure the reproducibility and transparency and the literature context in this package. And also there are many PhD students are using our package. So we have plenty email exchange with PhD students, and also there are many CRAN issues. So sorry, T-Hub issues online. So we also try to reply them. Also, there are master students who use this package, and also apply economists in governments or other agencies. They're also interested in our package. So now we have talked about the application of the package. So now we can talk about the engineering side of the package. So probably similar to Phil, and so he translated R code to Python. So what I did in this package is that I translated the MATLAB code from their research papers to C++ to make their code probably run faster and also more applicable to others people to use, to make them R package so that other people can use it more in a easier way. So yeah, we combine the algorithms that are written in C++, which are very fast, and also combine with the easy to use interface in R. And how we implemented the code in C++ is that we use Rcpp. So Rcpp provides essential functionality for package development. I think before the availability of Rcpp, it can be very difficult to combine R and C++ code. Now it's thanks to Rcpp and Rcpp, Armadillo, etc. Now we can easily combine R interface and C++ code. And it is manageable. We can use Rcpp to manage dependence, and with good combination by developer. I think the developer of Rcpp, he replies to online issues every day, which is very nice for us developers. And this package have a very great community support. And since C++ code is very super fast on looks, so and the deep sampler in Bayesian literature, which is used in the bsvars package, is a 0 drop. So it has to use a for loop. And then if you have to use a for loop, then using C++ is much better than using the R native for loop. And last point about the C++ implementation is that I think it's possible to parallel the code in our package, in the bsvarSIGNs package with OpenMP, but we haven't. So the open question for our package is that we haven't been able to find a way to set state in R and then pass that state to OpenMP and then parallelize the job. If anyone know how to do it, please let me know. And how we code the things in C++ is through Rcpp Armadillo. Armadillo is a linear algebra package in C++, and it's actually very simple to use. So it's like similarly to MATLAB, it's like writing matrix algebra in C++, similar to writing matrix algebra in MATLAB. I think the syntax is very easy to understand and very easy to pick up. And yeah, since this is written in C++, so the speed is very fast. And also we can ensure reproducibility from random number generators, as long as you don't use OpenMP to mess up the C. And it has a very excellent documentation and supporting package development. So there's an online document for Armadillo, and then you can search for anything in the package, and they will be very helpful. So the last point is that the C++ code is very easy to read. So as I said, the C++ code in Armadillo is just like reading MATLAB code, reading the matrix representation in MATLAB. I think it's very easy to understand. So how we delegate the code to C++ and R is that we put all the time-intensive tasks to C++. So that includes parameter estimation and computing the forecast and computing the impulse response functions, etc. We put all those computational intensive tasks in C++. And we only put the user interface code and also the data management or specifying the priors into R, so that which takes no time even in R. So we put this code in R, and then we put the time-intensive tasks that do all those computation, do all those for loops inside C++. And one benefit of using specifying the objects in R is that we can use the native ASIC objects for specification, and then we can also wrap the estimation and forecasting functions with a R function wrapper, so that it will be much accessible to other code groups. And also for this plotting and summary methods, so that people who use R, they are familiar with plot, summary, mean, etc. So if they can use these functions to, so the syntax is the same, and then you will be very intuitive to use. And the fifth thing in the design of our package is that we use the R6 management, R6 object-oriented system in our package. So as I mentioned, the first time I saw this in R is quite intimidating for me, but it's actually just creating an object. And if you are familiar with other object-oriented programming, this is just initializing an object from a class. So after you call this method, it will generate the starting values, the identification strategy, the data matrices, and then the prior hyperparameters inside a new R6 object. And then there are also many other things you can do with this specify bsvar $new method. There are also many other attributes you can. And one benefit of using this R6 object is that, similar to other objects from object-oriented programming, is that you can manipulate the public elements inside the object, but there are also private objects that cannot be manipulated. So it forces the user to not change some of the objects, and also it allows the users to change some of the objects, which is a very nice feature from the R6 object. So here's an example how we can change the things inside the spec object that is created from the specify bsvar $new method. So both this spec and after you call specify bsvar $new, you will generate this prior object inside the spec object, and itself is also another R6 object. And then since it is a object, we can manipulate its public views. For example, we can do $spec $prior $a, and then it is a matrix that contains the prior of the autoregressive matrix A. And then we can just manipulate the elements inside this matrix A. For example, we can change the first element, first column here from its previous value to 0. And then if we print the matrix out, you can see here the first column element has become 0. So manipulating the public view of the R6 object is quite easy in R. And then we can also call public method from this spec R6 object or the prior object inside the spec object. They are all possible because R6 it is the object-oriented programming system in R. And we also established a set of generics in the, you can say the father package or inside of the family of packages. The father package is bsvars, and then we implement this estimate, plot, etc. other generic functions, and then we can use it in the child packages like the bsvarSIGNs package. And then if you use depends and imports when you are inside your package declaration, then you can use the functions from the, and you can implement the functions. You can use the functions from the father package. So that in the end, we assure a similar workflow. So that users that want to use both package, the syntax will be very similar to each other. And similar to R6 objects, another object-oriented programming system in R is the S3 methods. So R6 is not a built-in package or library in R, but S3 is a R's native object-oriented programming system. It is available natively in R, and it can be used in a very simple way. So I think the goal of the S3 methods is to make the plot and summary functions, etc., accessible to everyone. So you can use plot the 4 letters here and then plotting anything you want here, and then you should work intuitively as long as it is implemented. So for example, in our package, and as you've seen in the previous slides, we can plot the forecast, we can plot the forecast error variance decomposition, we can plot the impulse response, and we can also plot the historical decompositions. And the only difference is that we implemented this plot of forecast, plot of posterior FEVD, plot of forecast error, and plot of forecast FGD. But in the end, when the users want to use these functions, they can just use the plot function here, and it can be applied to any of these 4 objects. So it's very intuitive for the users. You don't need to change the syntax. It's a very simple way to call the method. So even though I think R says this is a object-oriented programming system in R, but in my opinion, S3 is just you can define a function that can be used to apply to many different things or objects, but it's not an actual object-oriented programming system. But it's a very intuitive way to call the function and apply it to different objects. And another example in our package is that for the S3 method is that we use this estimated method. And this is an example from the bsvars package. So the syntax is similar. We start with some data, and then we pipe it into the specified method. And then in the end, we can call the estimate method. And then in the end, we can assign this to a posterior object. So here, this is an example of the bsvars package. We can call this estimator method. But you can imagine we can pipe this same data set into another specified method that's of a different class. Or we can still use this same estimate method for all those different specifications. So you can see here, it is very transparent. Our model is used here. So we can estimate the model where we specify bsvar object, or we can estimate the model with a bsvar object, or we can estimate the model with a bsvar SV object, and also in the bsvarSIGNs package, we can also estimate the object from specifying a bsvarSIGN object. So, but the essence here is that we can use the same method estimate here. So it is universal across all the objects, and it is very simple for the users to use. That's one benefit of the S3 generic and methods. So in our package, we try to export all the C++ functions to other developers so that when they import our package, they can also use our C++ functions. which can be used for some time. For example, when I'm developing bsvarSIGNs, I want to use a C++ function from the father package bsvars. Since all the C++ functions are exported, you can just reuse some of the functions from bsvars, and then it makes life much easier. However, if you don't export all the functions, if you just export the R functions and all the C++ functions, other developers that are interested in your C++ code might not be able to use it, unless they just copy and paste and not declare it. But if you export all your functions, then you can make things much easier for other developers. And it is also very easy to achieve this if you just put the package inside your linking tool or depends. When you hold out your package, then it should work. And also one minor thing I want to mention is that we experience a strange CRAN issue. So that is related to some pointer management. So we have one function from the bsvars package that updates an object by reference. So that the function does not actually return anything. It just updates the object that is put inside the function by reference using the pointer. But that function is in the bsvars package. And then if we call that function from bsvarSIGNs, which is another package, then it will create something called the unsanitized address management error, which is the CRAN issue we get. And we spent 2 days. We had to spend 2 days on the weekend to fix this, and it is very difficult to solve this. So the takeaway here is that it can be very difficult to work across different packages, and if you want to import a function from another package. So maybe the takeaway is to not use assignment by reference, and don't do update by reference, and then just to return the things you want. So another feature, one feature in our app is that we provide all the outputs, so all the posterior draws to the users. So if you specify the number of draws s equal to 5,000, we return all the 5,000 draws. So for advanced users, they can use these draws to do advanced things if they want. And for intermediate users, they can just use the plot and summary methods that can be simply used if they want to plot things, like to plot the impulse response or plot the forecast. And it's amazing how much you can do just with a few lines of code. So we also have many documentation for our package. So we have a package on our website for our package, and we also have social media channels, which I will show you yet. And also we update the most recent presentations. So all our presentations will be open source online. And we also have a vignette that is planned to be sent to the journal for digital software or the R journal. So future developments in our bsvars organization, we will. So there are many updates we are planning, and also we are also planning to make some new packages inside the bsvars organization. For example, bsvar panels, bsvar time varying parameters, TVPs, and bsvarCFs, and bsvar judges, and bsmarks, which is Bayesian structural matrix autoregressions. So these are all the upcoming packages we plan to implement in the organization. And this is the social media page I promised, and that's all today.
Thank you, Adam.
I have a demo. Yeah. I think you have to switch it. So while that's loading, first up, there's a lot to like about this package. Like, this is very well thought out, and I really like that you've thought about the users and you've thought about developers. And it's not always easy to take into account both groups, but yeah, the fact that you've actually tried to do that, I think, is really good. And I also quite like the design that you've thought about having a really nice workflow. So as I said, there's a lot to like about this, and I'm going to show a few things that I don't like, but they're minor compared to what a great package it is overall. So I thought I'll take one of the examples from your help file, and I thought first up, this is a multivariate model, so let's compare some univariate models and see how well it goes. So let's see, and I thought you're using TS objects. Here's my mouse. There we go. Using TS objects, so I'll use the forecast package. So I load your package, I load the forecast package. First up, I get told the forecast function has been masked, which is a problem because I want to use it. And if I go ahead and fit my forecast model, it works fine. And then if I go and fit your model, I get nasty errors because you've overwritten the forecast generic. And there's no need to do that. Like, the forecast generic exists in the generics package, and you could import it from the generics package, and then your package will play nicely with every other package that uses that generic, including the forecast package, the fable package, the smooth package. They all use this same generic. Because you've overwritten that, every other package is going to get broken.
And also one comment, actually it's a S6 object. You don't need to actually create a specific forecast method in the IO and S6, that every method is self-contained and could also have a forecast method within US financial LSU. So because it's an S6 object and the IO, this S6, everything is self-contained.
But I don't think you could write code like you
can, after that is developed, for example, you can make estimates, $estimate, $.
But you can't just use the generic directly. And they've tried hard to make it work nicely with a pipe. So I actually like the S3, but I think import the generic and then it works good.
Yeah.
Very good.
It's working well.
I'm going to start again because I couldn't go well. So I'm going to forget about my forecast package. I'll skip that. And now your function works fine. And it's incredibly fast. Like, to think about what it's doing, it is really fast, which is impressive. And I've just tried to spit the forecast to the screen. And the next thing I don't like is that I just get dumped with all of this on a screen. And again, that's not really necessary because you're using S3. Why don't you write a print method? So you've got a plot method and a summary method, which work really well. Add a print method, and then it'll just give a little output which says what it is without sort of vomiting the whole thing into the console, which makes it hard for users.
Suggestion on that is if you build as part of a framework, if you inherit from the forecast package, if you're trying to imitate the output, you can use the forecast package print method if your output is compatible.
Yeah. I mean, you're creating your own forecast class and you've called it capital F, so it's not going to clash with the forecast package. So you don't have to do it, but if you wanted to use the same thing, you could. Okay, so let's now fit a model and save the model, and I'll have a look at the model, and you do have a nice print for that, like you get told what it is. But for everything you do with that, like here's the compute some decompositions, again, vomits everything onto the screen. So you can have a print method for each of these classes, posterior, FEVD, and decomposition, and then you would just make it nice and look cleaner. You have a nice plot. So there's the plot. But if I want to modify those Y labels, I can't do it because it's pre-packaged, because using base plot. And I can understand why you might choose to use base graphics and not ggplot2 graphics, because it's lighter. You don't have to have another dependency and you want to limit dependencies. But from a user point of view, I want to modify that graph, and I can't modify a base plot, but I can modify a ggplot. So I mean, it's a choice, but I would say think about whether having some ggplot graphics would also be useful.
Yeah, maybe in future, maybe do it. Time to implement eSport GG.
Yeah, something like that. Okay, so let's do some forecasts. Again, we need a print method there. And if I do the plots of the forecasts, look on the y-axis, I no longer know what variable is which. You've lost the variable name somewhere along the line. The previous plot, the variable names were included, but in the forecast plot, the variable names seem to get lost.
Yeah, we are actually what.
Okay. And then over to a summary. Again, the variable names are lost. So I'll try and increase the size of this console. See this. Variable names are lost again, so you have to remember which variable is which is not always great. And I'm interested in these prediction intervals. We created some 90% prediction intervals based on the quantiles. To get access to them, there's no function in the package that I could find to get it out. I figured it out in an undocumented use of summary. I can grab the summary output, save it, pipe it into another function and extract stuff. So I can create the prediction intervals like this, getting what I want, but it would be nice for the user to be able to do that. And it would be relatively easy to do it. You could even just do an as.data frame around your object and it gives you a nice data frame or something like that. Last thing, well, not necessarily the last one. Next thing I looked at was, okay, I'm going to use exogenous variables, but if I don't give it, so my exogenous variables contain a certain number of rows, and they're the time periods for the forecasts I want to introduce. But if I don't specify the horizon, I get an error. You don't really need to specify the horizon because I'm giving it exogenous variables which have so many rows in them, and it should just be able to read the number of rows. I have to actually say, and if I give it the wrong number of, if I say I only want 4 horizons, but I give it 8, I will also get an error. Maybe that's a good thing, but maybe a warning would be better to say, hey, you've given me 8 forecasts in the exogenous variables, but you've only asked for 4. Here's 4 forecasts, but here's a warning just to remind you that there's an issue. And then the last thing is I want to look at the help file. So the help file for the forecast function in your package looks like this. And it's so very helpful information. But when I get to the examples, there's a lot here that you don't need. Like that one, totally unnecessary because the package uses lazy data. So you don't need to use a data statement. It's already there. You can get rid of that line altogether. You could potentially get rid of the C, but that's not a big issue. And then later, you keep setting the seed. I'm not sure why that was the case because you don't really need to. And again, more data statements that you don't need. So I would try, and there's a lot here. Like this is extensive for a help file for a function. It looks a lot, and it makes me think that this is complicated, but it's not. It's really well designed and it's really quite simple. And it would be good if the help file gave that impression that this was well designed and simple. Last thing is your data structure as an MTS object, a matrix time series object, which is fine for most economic data because it's monthly and quarterly. But a lot of people come to the package with a data frame, which might have quarters in one column and numbers in the next column. And there's nothing in any help file that I could find that says, how do you do that translation? And it would be nice to see an example, or for the package to be able to handle other objects, civil objects or something like that. That's enough, I think. Lots of suggestions, but they're not meant to say, yeah, I do like the package a lot. I think it's really, really well thought through, and just some simple things that would make it even better than what it is.